It says we are going to be talking about graphs of exponential functions today. This lesson will be split into 3 separate sections. We will cover questions 1 to 4. We will cover questions 7 to 13. And then we will round this lesson out with questions 14 to 18. Lots of information in this section, so please stay together. Recall that an exponential function is a function of the form f of x equals a times b to the x power, where a does not equal 0, b is greater than 0, and b does not equal 1. Use a graphing calculator to graph each function. Sketch the graph on the coordinate grid provided. B greater than 1 is over here off to the side. This says A is greater than 0. So let's take a look at what this graph would look like. So we're going to go to our graph, and it says 3 times 2 to the x power. And this goes from a negative 10 to negative 10 on all rounds. So we'll put that negative 10 to 10. And I'm going to do that again for our y. Make sure you change your scales to 1s. Okay. It looks like my y-intercept looks to be at 3. It looks like we're multiplying by 2 each time, so that would be 6 here. And then the next one would be 12, so it would kind of go up like this. Half of this would be 1.5. Half of that would be 0.75. So it looks to go something like this. Something like that, right? Notice that this line never actually goes past 0. It gets really close, but never should cross it. All right, let's take a look at B. B says, and I'm just going to turn this off by pressing the equal key. I don't want to actually clear it out because eventually I'll be looking at multiples together. Negative 3 times 2 to the x power. Notice I put that 3 in parentheses because it is negative. And we're going to graph this. Whoa. Okay. So this time, it looks like this. Oops, I should have. Like so. All right. Let's take a look at C. This time, 0 is less than B is less than 1. So it means that this number is between 0 and 1, but our A is still bigger than 0. So again, I'm just going to turn this equation off. I'm not actually going to clear it out. We want to do 3 times 2 to the x power. And, nope. Crap. Sorry. I didn't mean to do 2. I should have done 0.5. So I need to go down here. Let me put this one back in. And this one, clear that. This one should say 3 times 0.5 to the x power. Now graph it. This one's coming in from the other angle. Notice how it goes this way. This is still at 3. However, my 6 and my 12 should be over here. And this should be 1.5 and 0.75. So it comes down like this. And again, it should never actually cross. It's just going to come really, really close to it. And I want to actually change this number to say -3. So I'm going to turn this one off. We're going to go -3 times 0.5 to the x power and graph this. If I have to take a guess, I think it's going to be on here somewhere, right? Oh, that's what it looks like. It's coming up this way. So we're here. Got something like this going on. All right. Let's take a look. Compare and contrast the graphs and equations in items 1A and 1B. So we're looking at 1A and 1B. So these first 2 boxes. Okay. How are the equations similar and how are they different? How are these 2 equations similar and how are they different? Well, their B's are the same. The A is different. One was positive, one was negative. Let's take a look at 2B. Use words like increasing, decreasing, positive, negative, domain, and range to describe similarities and differences in the graphs. So again, we're just looking at these 2 right here. Use words like increasing, decreasing. This graph right here is increasing, but this graph right here is decreasing because it's going down. So function A is increasing. Function B is decreasing. Use words like positive and negative. Positive means what kind of y values are you dealing with? I mean, positive and negative are talking about your y values. So in this picture, your y values are always positive. In this picture, your y values are always negative. Function A is always positive. Function B is always negative. Domain and range. The domain of both is all real numbers. The range for A is all real numbers greater than 0, while this one is all real numbers less than 0. It's all real numbers less than 0. What connections can be made between the graphs and their equations? When B is greater than 1 and A is greater than 0, the function is always positive and is graphed above the x-axis. When B is greater than 1 and A is less than 0, the graph is always negative. And graphed below the x-axis. Compare and contrast the graphs and the equations of 1C and 1D. Okay, well, my A is different, but my B is the same. The B is the same. The A is different. Use words like increasing, decreasing, positive, negative, domain, and range to describe similarities and differences between the graphs. Function C is decreasing because it's going down, while function D is increasing. Function C is decreasing. Function D is increasing. This one is always positive because it's above the x-axis, while this one is always negative because it's below. So function C is always positive. Function D is always negative. The domain for both A and B are all real numbers. Oop, this one should say C and D, sorry. For both C and D are all real numbers. The range for C is all real numbers greater than 0. D is all real numbers less than 0. What connections can be made between the graphs and their equations? Okay. When 0 is less than 1, is less than b, which is less than 1, and a is greater than 0, the graph is always positive. And graphed above the x-axis. When 0 is less than b is less than 1, and a is less than 0, the graph is always negative. And graph below the x-axis. Graphed below the x-axis. I just mimicked what we did for number 2 here. Let's take a look at 4. Sorry. Describe the effects of the values a and b on the graph of the exponential function f of x is equal to a times b to the x power. Describe the graph of the exponential function when a is greater than 0. Okay, well, I know that the graph is always positive It approaches but never touches the x-axis. Describe the graph of the exponential function when a is less than 0. This graph is always negative. It approaches but never touches the x-axis. Describe the graph of an exponential function when b is greater than 1. When b is greater than 1, the graph approaches but does not reach the negative x-axis. Describe the graph of an exponential function when 0 is less than b is less than 1. The graph approaches but does not reach the positive x-axis. On to the wrap up of this section.